Moving on to section 1.5, we're going to take a look at these things called infinite limits. And this section will be all about giving us the language to deal with vertical asymptotes. So far we've dealt with places where we're continuous, where there are holes, where there are jumps. Now we'll get the language for our vertical asymptotes. To get us started, I'd like to take a look at the function f of x equals 1 over x, which I sketched over there. And we're going to take a look at three limits. Limit as x approaches 0 from the left of 1 over x, limit as x approaches 0 from the right of 1 over x, limit as x approaches 0 in general of 1 over x. Take a moment, pause the video, and make sure you have all this stuff copied down in your notes. None of these limits exist. This is how we started the unit. If we're not approaching a number, if the y values are not approaching a number, we say those limits do not exist. However, what we're going to look at now is a better way of describing how they don't exist. The limit as x approaches 0 from the left of 1 over x is what's happening over here. I'm going way down very fast. I'm not approaching any number, but I am approaching the idea of negative infinity. I'm going to say that this limit equals negative infinity. Yes, the limit still does not exist, but the better way to describe it, and what I'd like you to use from here on out, is we're going to say negative infinity as opposed to does not exist. The limit as x approaches 0 from the right of 1 over x. Well, as I'm approaching 0 from the right side, I'm going way up really fast. Again, not getting close to any number, but my y values are getting really, 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 really high. Those y values are approaching positive infinity. So I'm going to say this limit equals infinity. What do you think the overall limit is going to end up equaling? Yeah, this one is still not going to exist because from the left and right, I was approaching two different things. If I was approaching infinity from the left and infinity from the right, then I would say that's my overall limit. But because they're different, this limit does not exist. Okay, so what I'd like you to do is to take a look at that worksheet, section 1.5, Graphical and Numerical Limits. I'd like to see what you can do in problem number 1. Pause the video if you're watching on YouTube. Edpuzzle will just stop you. And see what you can do with those. Problem number 1. Okay, well, as I approach negative 2 from the left, let's see, here's negative 2 from the left. I'm going way up. That's going to equal infinity. As I approach negative 2 from the right, again, I'm going way up. That's going to equal infinity. Therefore, as I approach negative 2 in general, that limit is going to be infinity. Limit as x approaches 0. Well, from both sides, my y values are getting close to 1. That limit's going to equal 1. As I approach 4 from the left, let's see, 1, 2, 3, 4 from the left. Looks like I'm going way up, so I'm going to say that limit is infinity. 4 from the right, looks like I'm going way down. That limit's going to be negative infinity. And as I approach 4 in general, no, because those aren't the same type of infinity. This limit does not exist. See what you can do in problem number 2. As I approach negative 2 from the left, I'm going way down. That's going to be negative infinity. Negative 2 from the right, I'm going way up. That's positive infinity. As I approach negative 2 in general, because those didn't agree, I have to say this one, I'm just going to abbreviate, DNE does not exist. F of negative 2, though, that's a different question. That's asking what's happening right at x equals negative 2, not as I get close to it. So I'm going to say that that is just 1. Limit as x approaches 2 from the left. 1, 2, 3. I'm approaching 3 for a y value. 2 from the right. I'm approaching, looks like 1, more or less, as a y value. So the overall limit, no, that one doesn't exist because I'm approaching 2 different values. and f of 2, what's happening right there? 1, 2, 3. My y value is 3, right at x equals 2. One more. See what you can do in number 3 with the numerical limits. Let's see, as I approach 1 from the left, my y value is negative 10, negative 100, negative 1,000. They're going way down very, very fast. Because they're going down very fast, I'm going to say this is negative infinity. As I approach 1 from the right, my y values are going from 10 to 100 to 1,000. They're going way up very quickly. I'm going to say that limit is infinity. But because those don't agree, my overall limit does not exist.